So this is the next problem from again June 2016. So this problem states that there is an integral equation of phi, which is a function of x and t, which looks like lambda, and then integration over x prime t prime, and then omega and dk. And this looks like a Fourier transform to me. And yeah, and we have to find its equivalent differential equation. So how can we do it? So first of all, look at the options, how the options are there. So there in every option there is they have taken the derivative with respect to time as well as x coordinate, and then they have added or subtracted these m square plus or minus iota epsilon. So we will do also the similar way. So first of all, what we have, this one is the phi in the integral equation. Then we will calculate the derivative with respect to x. So now if you see here e raised to power iota k x minus x prime. So here x is not a what we say dependent variable of this integration, so we can directly take the derivative of this particular, and we will get if we take double derivative we will get minus iota k raised to power 2, and there is no other x from here, so we will just get minus iota k square, and the other all the thing will be similar. Now also remember I cannot pull out this k term out of this integral because there is dependent variable of which with respect to which the integration is happening. Now again we will take the derivative with respect to time, double derivative, and here we will take this iota omega from this exponential term here, so minus iota omega square because it is double derivative. Now what we will do, we will take a linear combination of these two things, so that the thing which is in the denominator that should be cancelled out, because this is a tricky thing. We cannot take the Fourier transform or do anything with by taking this term into the consideration. So what we will do, we will take the combination such that, see, this del square phi with respect to x, it is giving me minus k square, so minus k square, and then if I take with respect to this t, then I am getting minus omega square. So but in the denominator, if you see here, omega is positive, so I will take a negative sign here, and then the similar minus m square plus iota omega here. So all these terms will be cancelled out from the denominator, and what we will be left with is the lambda, and then integration with respect to x prime m t prime d omega dk, and then at this exponential. So in the right hand side we don't we only have this x prime x and t here in the exponential and this function. Okay, so now what we will do, we will try to solve it, and like by just arranging the terms. So keep the first two integration same, but put this phi cube x prime t prime in the front integral. Why? Because these two integrals which are with respect to omega and k, this function is independent of these two variables, so you can pull out of this integration to outward. Now I will divide this 2 pi into 1 2 pi as well as root 2 pi and root 2 pi. Okay, so why I am doing this, because if I do so, then this particular bracket will give me the general formula for a Dirac delta function, so, with t minus t prime here, and this other one will give me the Dirac delta function with respect to this x variable. So these two will give me two Dirac delta functions, and this 2 pi I can place at front. So now what we have is dx prime dt prime and this function again, and then two Dirac delta function. So what we can do, we will use the property of Dirac delta function, that whenever we do an integration of Dirac delta function multiplied with some other function, then the value of the integration will be just like here. It will be in place of x prime you will replace with x, and in place of t prime you will replace with t. So we will do the same and we will get lambda and phi cube and x phi cube as a function of x and t. So this option is matching with the option number 4.